Here's a trinomial x squared plus 8x plus 16. We can probably do this in our head, but because there's something special going on here, I'm going to make a chart, and we know that 1 times 16 is 16, 2 times 8 is of course 16, and also 4 times 4 makes 16. But for this trinomial, we definitely want the 4 and the 4 because 4 plus 4 equals 8. So there's our factored answer. But both binomials are the same, so they can be written like this with an exponent, and the trinomial is called a perfect trinomial square. Here's another. We don't need to make a chart here. Once we look at 25 and know that that's a square number, we say, well, 5 times 5 is 25. Does 5 plus 5 add up to 10? And it does. So there's our pair of factors. They're identical, so we can use an exponent. And here's one with a negative for the middle term, but since negative 7 times itself is 49, and negative 7 plus negative 7 is negative 14, that works. Only these two binomials involve subtraction instead of addition, but we can still write them with an exponent. This one's more complicated because for the first time in 2 lessons, we have something besides 1 as the coefficient of x squared, and it's the number 9. But the number 9 is a perfect square because it's 3 times 3. And the number 4 is also a perfect square, 2 times 2. So let's write it as 3x plus 2 times itself and see if that works. Well, we know that the 3x times the 3x is 9x squared, and the 2 times 2 is the 4. But let's look at the terms that involve x to the first power. We have a 3x times 2 to make 6x, and a 2 times 3x to make another 6x. That's where the 12x comes from. So this works, and here's how we can write it with an exponent. Here's an unusual problem because it's a binomial, not a trinomial. But we can write it as a trinomial if we want. Just realize that the middle term, the x to the first power, is 0x to the first power. And now we're looking for two numbers that multiply to make negative 81 that add up to 0. Well, of course, that's positive 9 and negative 9. And you can't write this with exponents because it's not a perfect square. They're actually different factors. They're definitely related because of the negative 9 and the positive 9 being opposites. But this binomial at the top, x squared minus 81, is called a difference of squares. And a difference of squares can be factored. And in this example, it's shown in the third line, factored into the binomial x minus 9 times another binomial x plus 9. Here's another difference of squares. You look at the 144 and you say, what's the square root of 144? It's, of course, 12. So our answer is x minus 12 times x plus 12. And here's a difference of squares that's more complicated. But again, the 36 and the 64 are both perfect squares. So we get 6x minus 8 and 6x plus 8. And, of course, the middle terms that are opposites are a positive 48x and a negative 48x. So they disappear, and that's why it's a difference of squares, and it's a binomial and not a trinomial. Here's a list of all the square counting numbers less than 1,000, from 1 to 961. 961 is 31 squared. And when you see these numbers in binomials and trinomials, look them over to see if you could be working with a perfect square trinomial or perhaps a difference of squares. And here's a fun problem, at least I think so. We have x to the 8th power take away 1. Well, the square root of x to the 8th is x to the 4th, so that's a difference of squares. Now, the factor on the right, the x to the 4th plus 1, is not factorable. A sum of squares cannot be factored. So we just recopy that factor, but x to the 4th take away 1 is still a difference of squares. It factors as x squared minus 1 and x squared plus 1. Now in the third line we have 3 factors. 2 of the factors of sums of squares. They cannot be factored, so we'll recopy them. But the first factor, x squared minus 1, is a difference of squares, and we write x minus 1 times x plus 1 times the other 2 factors. So we've taken a difference of squares, x to the 8th minus 1, and factored it into 4 factors as shown in the 4th line. A perfect square trinomial can be factored much like other trinomials, but exponents may be used when writing it in factored form. If a binomial can be factored as a product of two other binomials, then the binomial is a difference of squares.